Assalamualaikum and hi. We are from group B1. We are doing the experiment about activated carbon adsorption in wastewater treatment. Okay, so adsorption process by liquid phase have been shown to be highly efficient for removal of colors, odors, organic and inorganic pollutants from industrial process or waste effluents. The activated carbon, either in powder or granular, is widely used because it is the best adsorbent in absorption capability for organic compound. Unfortunately, it's a little bit costly because it might be limited in industry. There are many research about to replace activated carbon with something cheaper but still having the same function. Therefore, fly ash, silica gel, wool waste, blast furnace sludge and clay materials can be used. These materials have been already studied with varying success for removal of color and organic matter. In this rapid industrial developments era, the pollutant in water bodies due to industries become a major issue. It is believed that a large amount of dust, approximately 20% of global production, is discharged by textile industries, include incomplete exhaustion of coloring material and washing operations. Those disposal from the industry poured into the water bodies not only affected the nature, but also being a disturbance with the penetration of sunlight from delivered into the water ecosystem. The component in dust that have been dumped into the water bodies are mostly toxic and even carcinogenic to both animals and humans. It is very harmful to them. Okay, there are many research deal with the capability of adsorption technique in removal of diphenyl red from wastewater. As the diphenyls red are content of toxin, it can lead to irritation to the eyes, messing with respiratory system and skin. There are some effective technique but costly for the removal of dye from wastewater by employing two waste material, which are bottom ash and the oil soya. Both are adsorbent materials and they are easily found and abundantly. Bottom ash can be found from coal-fired station, while the oil soya can be found from animal feeds. Okay, that's all.
Firstly, we will need to weigh methylene blue. And after that, we are going to weigh 5 milligrams of activated carbon. Once they are all weighed, be sure to label all of the substances as shown in the picture. Next, fill beakers with 1 liter of distilled water. Make sure you have 5 different beakers to fill in your methylene blue. As seen, the first beaker has 50 milligrams followed by 75, 100, 125 and 150. Then fill in the methylene blue in the respective beakers. Also ensure that all beakers are labeled to avoid any form of confusion. Next, when all methylene blue is inserted in their respective beakers, we stir them with 120 RPM for about 5 minutes. After that, put in the activated carbon in each beaker. Also prepare a 10 milliliter sample beaker to collect the samples after we have mixed them. We will mix the mixture for 120 RPM and leave them for 5 minutes consecutively after each sample is taken. Now we will take the sample of methylene blue from the respective beakers. Each sample will then go to a spectrophotometer to record the refractive index. Before recording, we must calibrate it with distilled water and make sure the refractive index is 0. And then check the refractive index of each sample as seen. Don't forget to repeat it for the next 5 minutes.
Hello, my name is Susenthirah Selvakumaran and I will be talking about the results and discussion of our experiment on activated carbon adsorption. We have carried out this experiment on objective A, which requires us to obtain at least 70% of removal efficiency of methylene blue by using activated carbon and determine the best fit of adsorption isotherms, which is for Langmuir and Freundlich together with its respective isotherm constants. So, first of all, we need to calculate the concentration of methylene blue adsorbed onto the activated carbon. Here, we will be taking 5 different concentrations of methylene blue, which is 50, 75, 100, 125 and 150 milligram per liter of methylene blue into the activated carbon. So, here in this equation, the M stands for the mass of the activated carbon, V is the volume of the solution, which is 1 liter in our experiment, C0 is the initial concentration of the methylene blue, which I was mentioned earlier, and then Ct, concentration of the methylene blue adsorbed onto the activated carbon at time P. Next, we should calculate the equilibrium concentration of methylene blue adsorbed onto the activated carbon. We have used the formula shown here to calculate the equilibrium concentration. So, the QE stands for the equilibrium concentration of methylene blue, C0, initial concentration of methylene blue, CE is the equilibrium concentration of methylene blue, which we get from the calibration curve, from which we attach in the appendix, and M is the mass of the activated carbon, which we have used 5 mg in our experiment, and the volume of the solution is just 1 liter. Next, we need to calculate the ratio of the methylene blue concentration to its initial concentration. So, we have used the formula shown here to calculate the ratio. So, the C stands for the final concentration at a given particular time, and C0 is the initial concentration of methylene blue solution. Following is the removal of efficiency is talking about how much of methylene blue particles is removed from the solution. So, to calculate that, we have used the formula shown over here, whereby the C0 is the initial concentration of methylene blue and Ct is the concentration of methylene blue at given particular time. Now, we have reached to the interpretation of our data. According to the theory, it is said that the concentration of methylene blue should decrease over the time. Due to the unavoidable error occurred during our experiment, we could not get the actual results on that. But, however, we have obtained the slight decrease in the concentration of methylene blue at 100 mg per liter. This is shown in our graph there. Over here. This is the part whereby the concentration of the methylene blue decreased at that particular time. Next is the removal efficiency versus time graph. In this graph, we have shown that almost all the concentration have achieved 90 to 94% of removal. So, we have achieved one of our experiment. And we also need to state that the removal efficiency is the highest at 50 mg per liter. Then, we need to look at the equilibrium concentration versus time graph. At this graph, the equilibrium concentration of the solution has attained a steady state over the time. This is because we have provided the constant rate of stirring of 120 rpm for 5 minutes. Next, we shall look into the Langmuir isotherm graph. We have several ways of determining or defining adsorption. There are Langmuir isotherm, Freundlich isotherm, or even a linear isotherm. Now, we shall look into Langmuir isotherm. From Langmuir isotherm, this is the equation that we have obtained, or this is the equation that we have used. So, this is the linear equation that we have get from our data. So, K is the adsorption constant which we get from here, and then we change into the inverse of our linear graph, which stands for the gradient is negative 0.0002, so we get our adsorption constant as negative 0.2. From there also, our y-intercept is 1 over q max, and then that value is 4 exponential negative 5, so we can calculate our q max as 25,000. We shall look into the Frenlich isotherm. This is the Frenlich equation that we have used to calculate the Frenlich isotherm. The Frenlich isotherms is another way of determining the adsorption isotherms. Hence, we have calculated the constants for that too. For K star, which is the adsorption constant, we have obtained 11,898 and the n is 0.15797. Both of these values we got from our linear series. That's all from me, and this is Susenthirah Selvakumaran officially signing off from CDB 3052. Thank you.
Okay, Assalamualaikum and hi everyone. My name is Ernie Fatriyah. Today, I will conclude about our experiment that can be implemented in industries. As for the conclusion, our objective of these experiments is actually we want to study the kinetic reaction of the activated carbon by using different concentration of methylene blue. By this objective, during our experiment, we can see that the different result of the effect with by using different concentration of methylene blue. Actually, activated carbon is highly efficient for removal of colors, odor, organic and inorganic pollutants in industries. So we have decided to make sure to implement in our industries that by using wastewater treatment for our experiment of activated carbon. Okay, so in the industries, we have choose activated carbon filter to be used as the method of separation for this application of experiment in industries. This is due to it is easy to install and efficient to remove certain organics, and base we also consider on material availabilities. However, the filter is hard to find it. That is one of the advantage for our activated carbon filter. So there are 4 stages in the wastewater treatment, which is preliminary, primary, secondary, and tertiary. Actually, preliminary is the basic of the treatment, which is it filter the bigger size of the unwanted substance. And for the primary, it is the consequence from the preliminary and then the primary, and then by using biological treatment is in the secondary, and lastly is the tertiary, because tertiary is to remove suspended and dissolved substance. So that's why we are choosing activated carbon filter, which is the last treatment, tertiary treatment in the industries, because carbon filter activated carbon is the dissolved substance that we need to use by using tertiary treatment. So in our project, we also consider about the other factor, which is the customer factor, safety, and also economics. So the customer factor also take the main role of the industries to ensure that um, we are giving something to the customer, not because we are needed, but the customer need it. So that is one of the main important consideration that we need to take place. So as for our research, we have seen that many customer demand about the activated carbon, especially about the tertiary treatment, since the tertiary treatment is the high cost treatment that we need to run. So we also consider about the economic. How does it efficient to run this treatment in these industries? So in this economic consideration or economic analysis, we evaluate the economic feasibilities, we investigate the cash flow, and compare the economic quality of different technologies. Therefore, we can find the most efficient with highly technology of the plant to run. And also, we didn't forget about how does the safety of the worker need to be considered, because in a plant, to ensure that in a plant we have a worker, so to make sure that worker have a safety and also their health is very important. So it should have a safety committee that officially that officially investigate about the situation of the plant, about the substance, and also everything about the safety and also health of the plant. So in industries, we should have many factors, and also we should also consider why do we do wastewater treatment, because wastewater treatment is the one of the what we call is the one of the is the one of the trying and to ensure that our environment is safe and also environmental control, right? To prevent from the wastewater to be destroy our earth, and also make a high risk towards the communities and also the residents, especially child and the woman. So that's all I think. Yeah, it is the conclusion of our experiment. So we choose activated carbon filter in wastewater treatment industries.